Teaching path for railing of 5-axis cantilever machine 5. Today we'll teach these corners welding. First, let's see the drawing of the design. The corner in here. The Y is easy. 20, 140, adding 160, adding 180, 160, 180, minus 10. From here to here, to this corner, makes 650. But how to calculate the x coordinates? We have to test for a while. At the last, we get these coordinates x minus 550. The z equal to 0. And how about this point? This point is minus 575x. The y is 60. 670. The z 0. And then the welding in here goes up to here. The x moving positive first, then minus direction to the toughest points in here. While the welding from here to here, the x always positive, the y always minus direction, the z always positive direction. Let's see how to teach this corner first. First, we have to change to teaching modes and use add 1 last. The K use move K8. Get the current parameter 100 millimeter per second. This point, the x is minus 550. The y coordinates is 650. The z 0. Okay. And then we'll incline the tool. These points, welding points, no change position. So we have to use Cartesian coordinate system. Y minus first once, twice, 3 times, inclined 30 degrees, and rotating about z plus once, twice. Okay. This angle. Okay. Then we have to change back to drawing mode and modify, get machine coordinates. Okay. Then let's retract the tool. Before line number 1, we have to insert another instruction and then change to Cartesian coordinate system. X minus once, twice, 3 times. Change back to drawing mode and modify the line number 1. Get the machine coordinates. Okay. And then the number 1 line, insert another coordinates, another instruction, and move to the line number 1. Use Cartesian coordinate system. Y minus rotate the B axis back to 90 degrees. Right now, 94. Slower the speeds. Y plus 93.0, 92, 91, 90.7.2. Slower the speeds. Another direction, continue. 89, 89.8. Okay, 90 already. So the B axis, okay, change back to join mode. Use modify, get machine coordinates. Okay. Then the C has to turn to 0. Insert 1 in front of instruction 1. Move to the new instruction 1. Right now, J5 minus 143. The speed to the fastest. J5 minus, so we have to use J5 plus to turn J5. Okay, slower. Slower. J5, 0.2, 0.1, 0.0. Okay. And modify the instruction number 1, get the machine coordinates. Okay. And then insert 1 line and move to the new instruction 1 to the fastest speed. J3 plus once. Lift the tool up 10 millimeters. And then modify the first line, get the machine coordinates, and change the U to exactly 0 degree. Change the V to exactly 0 degrees. Okay. Then the C run. Head, tail to tail. Right now, the 9.5 already is. Then we have to climb up to the top of the tube. Let's change the direction, view direction, to see from this side. Okay, good. We slower the speeds to modi 10. First, J3, 1 up. J2 minus 1. Oh, J2 should be plus 1. J1 slower. Okay, this point fine. So you lock these points by using line. Next, J3 plus J2 plus J1 minus, slower the speeds, J1 plus. Okay, these points 5. Lock these points by using line. Okay, slower, J3 up, J2 up, Y positive direction, J1 minus direction. Good. Use line to lock these points. And then J3 up, J2 move in positive direction, J1 minus direction. So this is the toughest point. And lock this point. Then retract back. Change to Cartesian coordinate system. Speeds to the fastest. S minus once, twice, 3 times. Change back to join more. Lock these points. Then let B angle be 0. Back to Cartesian coordinate system. Ry minus once, twice, 3 times, 3rd times. Right now Ry 94. Lower the speeds. Going Ry plus 93, 92, 91, 90.7, 90.2. Slower the speeds. Over. Go back. 89.8, 89 okay, 90, exactly 90 degrees Ry. Change it back to join more and use line to lock this point. Right now, the J5, not a 0. Let's adjust the speeds to multi 1000. Use J5 plus once, twice. So the J5 slower, bigger and bigger. At last, approach 0 degrees. Slower the speeds. Approaching 0 degree to the positive direction. Okay, 0.072. Okay, now use line to lock this point. And then fastest speeds, J3 plus once. Lock this point, but modify its U to 0 degree. It's V to 0 degree. Okay. So totally 13 instructions. Let's see the simulation. Wrong. Okay, perfect. Then save CC. The file give test 5.cc. Save it. So this side finished. Then we have to simulate the upper part. Renew to clear the data field. The cell locate the point by add one last. The K give number A. Get the current parameter 100 millimeter per second. And the X minus 575, Y 67 0, Z 0. Okay. Then incline the tool by Cartesian coordinate system. We have to incline this direction. We can use RZ. Turn once, twice, 3 times. Okay, this pose, no problem. So we have to change back to join mode. Use modify to get motion coordinates. Okay. Then inverse to get the previous toolpath. Insert one line before instruction 1. And use Cartesian coordinate system. Use S minus once, twice, 3 times. Change back to join mode. Modify, get motion coordinates. Okay. Then insert another one. Move to new instruction 1. Turn the B tool to 90 degrees. Change to Cartesian coordinate system. Use RY minus once, twice, 92 already. Slow the speeds. RY minus or wrong direction. RY plus 91.5, 91.9. Slower the speed, 90.2, 90 degrees already. Change back to join mode. Use modify, get the motion coordinates. Okay. Now insert. Move to new line number 1. Right now J5 minus 171 to the maximum speeds. J5 plus once, twice to turn the J5 to approach 0 degree. Lower the speeds. Minus 0.3 minus 0.1 plus 0.067. That's fine. Modify, get motion coordinates. Okay. Then insert another one. Move the new instruction 1. Speed to the fastest. J3 plus lift 10 millimeter high. Then modify the first instruction. Okay, don't forget to let U just 0, no error allowance at all. UV or 0. Okay. So we have to climb to the top of the tube. Let's round it. Let's head tail to the tail. Right now, instruction 5. Okay. Closer to climb from here up to here to create the instruction 6. We lower the speeds to 10, just 3 plus once. The J2 minus direction once. then J1 plus direction once. Okay, join more, no problem. Use line to lock this point. The next one, J3 once, J2 minus once, J1 plus once. That's fine. Lock this point. Then next one, J3 once, J2 minus once, J1 plus once. Closer to look. Okay, then lock this point. Then J3 once, J2 once, J1 still has to move. Okay, lock this point. And then J3 lift, J2 minus J1, moving, 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 moving. Okay, lock this point. Then J3 up, J2 minus direction, J1, moving, moving. This is the toughest points. Okay, line. Okay, let's run to see how they work. Perfect. Then change to Cartesian coordinate system. The speed to the maximum. Use s minus 1 twice 3 times. Change it to the join mode. Lock this point. Then next turn B angle to 90 degrees. Change it to Cartesian coordinate system. Y minus 1 twice 92. Slower the speeds. Y minus long direction. 92, 91, 90, 90.9. Slow the speed. 90.9, no change. Okay, over. Y minus 89.5, 0.7. Already. Change it back to join mode. Then lock these points by using line number 13 created. Then J5 minus 171 has to be altered to 0. So the speeds to the fastest. J5 plus turn, 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 turn. Okay, minus 1.333. Continue to turn, turn, turn. Right now J5 0.067. Okay, lock these points by using line. Then lift the 10-minute speed to the fastest. J3 plus 1 up and lock this point. Use modify to let U just 0, V exactly just 0. Okay. The total instructions 15. Let's run. Have a look. Again. Okay, perfect. So we have to insert this size root before line number 1. So head tail, move to the head number 1 by using insert file. Insert the file, test the file .cc in, and let's run to have a look. Okay, no problem. Save cc. In the same, use test5 .cc and save it. That's all.